Okay, today we're looking at the notes for writing linear inequalities with two variables. So let's first look at these type of symbols. We all know the equal sign. Okay, it's two solid lines like that. We have the greater than. When we use the term more than or larger than, that's what that means. We also have less than. When we use the term fewer than or smaller than. We also have greater than or equal to, at least, no less than. That's where we use those ones. And then the final symbol, less than or equal, where we use the terms at most or no more than or the term maximum. Graphing wise, get in the habit of drawing this out. And you can go ahead and arrange them in any order. What you'll notice is I'm going to try and use the lines on this side, the dashed and solid lines on this side. And then I'm going to do down or below, and then up and above. So for dashed lines, that's going to be my greater than and less than. And if I'm shading below, that's my less than symbol. If I'm shading above, that's my greater than symbol. When it's a solid line, it's the greater than or less than or equal to. When it's below, it is the less than or equal to. When it's above, it is the greater than or equal to. So we're going to go ahead and write an inequality that represents each of the representations. So we want to start off whenever we're given a graph or a table. We want to start off trying to go into slope-intercept form, mainly because if we start in slope-intercept form, it makes it easier for us to get it here, and then we can get the correct inequality. And if we have to convert it into standard form or a different form, we can from here. So looking at this, it looks like it goes to the point -2, and it goes to the point 3. So I have two options here. I can either use these 2 points in Desmos and do a regression, or I can use the facts of slope-intercept form, which is y equals mx plus b. M is my slope, up 2 over 3. So up 2 over 3. As it goes from left side to right side, that's a positive slope. So that's positive. So it stays as 2, 3. And then plus my y-intercept, which happens to be -2. So now that I have my slope-intercept form, now I'm going to identify my correct inequality. So y 2/3 x minus 2, all of those are shared with this. The part that changes is because it's a dashed line and it's shading down. So dashed line, shading down. That is the less than symbol. Okay, now converting it to standard form. So here's what I'm going to do. Remember, standard form is ax plus by equals c. Remember, the rules are a, b, and c have to be whole numbers. A will have to be positive. And then nothing besides 1 can divide each one of these. So, which will be perfectly fine. We'll go ahead and work this out. We'll start with y is less than 2/3 x minus 2. The very first thing I'm going to do is I don't want to deal with this division right here. That's going to complicate things. Okay, if I have to do it multiplication or something else like that later on, that's perfectly fine. I'll live with it. The first thing I'm going to do is I'm going to multiply everything by 3. 3 is my denominator here. If I multiply everything by 3, that's going to eliminate my denominator. So this becomes 3y is less than 2x minus 6. 3 times y is 3y. 3 times 2/3 x, it becomes 2x. It eliminates the denominator, which is what I want. 3 times -2 becomes -6. Okay. Step number 2. Remember, it's ax plus by equals c. So I need to move this x value over. And when I move that x value over, it's crossing the sign. So as soon as I move it, it becomes negative 2x plus 3y is less than -6. Now I have to do my last step, which is this. The rule is with A, okay, with A, B, and C, they all have to be whole numbers. Or they all have to be integers. 2, 3, 6. Perfect. No decimals, no fractions. Great. Secondly, nothing can go into each one of them besides 1. The only thing that can divide all 3 of these numbers is 1. 2 can divide 6 and 3 can divide 6, but 2 can't divide 3 and 3 can't divide 2 nicely without getting decimals. The problem is going to be that the A value has to be positive, and right now it's negative 2x. So I need to multiply everything by -1, and I have to Uno reverse everything. So instead of negative 2x, it becomes positive 2x. Instead of positive 3y, it becomes negative 3y. Instead of -6, it becomes positive 6. However, I just multiplied an inequality by a negative value, which means this sign has to flip. And if I want to test this out to make sure that it works, here's what I do. I pick a point that I can use all the time, and it's super easy to use. I'm going to use my favorite point right here, 0, 0. Should 0, 0 work? No, it's not in the solution set. Okay, so let me test it out. 2 times 0 minus 3 times 0 is greater than 6. 2 times 0 is 0. 3 times 0 is 0. 0 minus 0 is 0. Is 0 greater than 6? No, it does not work. Good, it's not supposed to. It's not in the solution set. So I know that my inequality is facing the right direction. If I had this, if I didn't flip it, it would have said 0 is less than 6, and that would have been true. So therefore, I have this shaded incorrectly. So the fact that I knew that I had to flip it because I multiplied by -1, I verified that part. So we're good. This is our final standard form. Number 2, a table shows some pairs and a line on a boundary line that are included in the solution set of a linear inequality. If the point 1, 2 is also in the solution set of the inequality, write an inequality in the slope-intercept form that represents the data. So, slope-intercept form, y equals mx plus b. Sweet. That means I don't have to do this part. Okay. All right. So what I can do is I can plug all of this in. I can plug this entire table in, and I do a regression, and it will tell me what my, it'll also tell me what my slope and y-intercept are. However, I don't have Desmos up. So what I'm going to do is I'm going to do this. This changes by 2. It goes up by 2. It goes from -2 to 0. This changes by 3. And it goes up by 3. -8 to -5 is 3. So my change in y is 3. My rise is 3. My run is 2. So my slope is 3 over 2. I also have the added benefit of this. This is my y-intercept. Remember, y-intercept is the value of y when x is 0. So I have my slope, 3 over 2, x. I have my y-intercept, -5. However, it's telling me 2 things in here. Number 1, it says the table shows some points that lie on a boundary line that are included in the solution set. So that tells me my line is solid, less than or equal to, greater than or equal to. The second piece of information it gives me is that the point 1, 2 is also a solution. So what I need to know is I need to know if 1, 2 is going to, if this would be above the line or below the line. So if I graph this real quick, I'm going to go ahead and pull Desmos up at this point. And unfortunately, you can't see it, but if I graph it, y equals 3 over 2x minus 5. The point 1, 2 is above the line. So if it's above the line, that means it's going to be above and it's going to be solid. So the greater than or equal to. So y is greater than or equal to 3 over 2x minus 5. You can also solve this algebraically. Plug in 1, plug in 2, and see if it's supposed to be 2 is greater than or equal to this, or if it's supposed to be 2 is less than. And judging because of the negative 5, 3 halves is 1.5. 1.5 minus 5 is negative 3. So 2 is supposed to be greater than or equal to negative 3. Last problem. The verbal description problem. It looks like we're going to have to write the inequality, graph the inequality, and identify 2 solutions to this inequality. A student is ordering snacks for an upcoming study session and does not want to spend more than $20. Muffins cost $4 each, bagels cost $2 each. Write an inequality that represents all the possible combinations of x, the number of muffins, and y, the number of bagels, the student can purchase for the study session. So if it's $4 for muffins, $2 for bagels, and does not want to spend more than $20. So the muffins cost $4, so 4x. The bagels cost $2, 2y, and doesn't want to spend more than $20. Well, the price of the muffins and the price of the bagels, you would have to combine them to figure out how much you're spending. So you're going to add between them. And you don't want to spend more than $20. So you want to spend less than it. Now the question is, you does not want to spend more than $20. More than or at most, when you think about this, does not want to spend more than $20. Are they okay with spending $20? Based on how this is worded, that sounds like it's correct. They are okay with spending $20. They do not want to spend more than that. So my inequality is 4x plus 2y is less than or equal to 20. So boom, that's my inequality. It doesn't say what form I have to write this in. I'm choosing to write it in this form. But now it wants us to graph this inequality. So if I have 4x plus 2y is less than or equal to 20, let's go ahead and solve for y. I'm going to subtract the 4x over. So it becomes 2y is less than or equal to negative 4x plus 20. My next step is I'm going to divide everything by 2. So y, 4 divided by 2, that's negative 2, because that's negative 4x. And 20 divided by 2, that's 10. Now the question is, my symbol, does it change? I divided by a positive value. So because I divided by a positive value, that means it does not change. Okay, so because we did not divide by a negative value, our sign stays the same. So let's go ahead and graph this. It is right here, starts at 10 and goes down by 2 every single time. So over 1, down 2, over 1, down 2, over 1, down 2, over 1, down 2, over 1, down 2. Because it is an equal to, this is a solid line. Okay, now the question is, which way do we shade? Do we shade up or do we shade down? So here's the thing I need you to think about. First, it is less than or equal to. So already this says that we should shade down, right? Here's the other thing I need you to think about. Does it make sense to shade above? Would you, if they do not want to spend more than $20, would it make sense that they would buy anything that's above this? Like 1,000 muffins, 1,000 bagels, that doesn't make any sense. So no, we would shade down. Now, if there was something else like, oh, you have to spend this much and then you get something, like spend this much and then you get a free muffin or a free bagel or free coffee or something like that, then yes, that would cause this to shade up. But, or like free delivery or something like that, like a DoorDash type thing. But here, they don't want to spend more than that, so they want to shade down. So we graph the inequality. It looks like this. Here's another way that we could verify our values. Ready? We could just do this with 2 points. How many muffins could they buy total? The muffins cost $4 each. X value is our muffins. So 4x equals 20. You could divide by 4 and x equals 5. That is the most amount of muffins that they could buy. Here's the second part. We could do the exact same thing here with bagels. The bagels cost $20 or $2. They want to spend $20. You divide by 2, y equals 10. Right here. And this is our bagels. So we know that our bagels are correct and we know that our muffins are correct. Last thing, identify 2 different solutions for this inequality. Well, this is all of our solution sets. So any values in here work perfectly fine. You could buy 1 muffin and 6 bagels. You could buy 4 muffins and 1 bagel. You could buy 1 bagel and 1 muffin. Okay, anything in here, the values that do not work here, decimals. You can't buy half. You can't buy half a bagel, can't buy half a muffin. Okay, you can split them once you get them, but you can't buy them that way. Also, what also doesn't work is anything above this line. So 2 solutions that you could have, we could have 4, 1, and we could have 1, 6, or 1, 4, or 1, 1, or 0, 0. Any one of those would be solutions. And that's it. That's your notes on graphing inequalities with a verbal description or from a graph or from a table. So writing the inequalities.